Welcome back to part 3 of our live training session here with our turbocharged BMW M3 running on EMU black standalone system. Now in the last video, we got our engine fired up and running. We have the idle control sorted out. We know that it cranks and it fires and it has appropriate air, fuel, and spark in the variable cam timing, so the engine is holding its own idle. Now, this video we're going to be turning our attention into doing our part throttle cruise area of operation and calibration process. This is going to be including taking a look at our fuel and our spark timing, and also optimizing our fuel injection timing, and also taking a look at the acceleration enrichment. There's going to be a bunch of things we cover within the training tutorial here, so let's jump in so we can get started. Welcome back to our live training session here with our turbocharged BMW M3. Now, last video we sorted out starting and getting the engine to idle. Now we're ready to turn our attention into actually starting to drive the vehicle and doing the calibration process, looking at our part throttle cruise area of operation. We want to slice down the calibration process into separate sections so we can manage things very easily. We're not going to go try to start dealing with idle control and driving and wide open throttle at the same time. We want to make sure that we're taking things in smaller chunks and smaller steps so it's easier to deal with. That's what we're going through in the calibration process here, just breaking it down, making sure that everything makes sense and you can go through things very slowly. So the first order of operations, get the engine up and running, get it idling. Next order of operation is going to be doing part throttle cruise. So what we're going to be focusing our attention on in this video is optimizing fuel and spark part throttle. So that is going to be, if we look here at our main VE table, now our main VE table is going to be alpha N base. We define its throttle position because this is individual throttle bodies on this particular engine, which is why we're running throttle position. If you're running map pressure, the calibration techniques are going to be the exact same thing. It's just going to have a different load axes. But what we're focusing on is essentially 40-50% throttle and less. It's going to be our cruise or normal driving area of operation. So in this table, if we're kind of looking at this, we're kind of slicing it away. This will be everything off idle. So idle here is roughly 1,000, so 1,500 and higher, and going from roughly 40-50% throttle and down. So in this range, this is where we're going to be focusing our efforts in calibrating. Now, some things about alpha N tuning that might differ a little bit compared to a map pressure based or speed density based tuning if you have that option selected. You'll find that in a alpha N based mapping here that the values, the VE values, will be a little bit lower in part throttle compared to a map based table. That's because there's a little bit more a different relationship with throttle angle versus volumetric efficiency compared to map pressure versus going through at that same kind of range that you would be driving in or expecting to drive in. So the values are generally going to be less in a alpha N table off idle compared to having kind of the opposite effect with map pressure, where they're going to be ascending as we go up in engine speed. So that's going to be one little difference here as we're going to be finding and we're going into this video. Now, our goal is to make sure that we're going to be hitting our target lambda or target air fuel as we're driving in that range. So we're going to find here, if we're taking a look at our map, in our target air fuel or target lambda map, we have everything set to roughly 1.0 lambda at idle and part throttle in our driving. So our goal is to calibrate and represent the airflow or air mass from this table properly so that when we're driving, we're hitting this target air fuel. In a perfect world, we'd be able to calibrate this and everything would be 100%. Now, in real world application, every time we drive to the table, there's going to be some differences. There's always going to be a slight variation, and that's where we're using the EGO correction to fill in the blanks or fill in the gaps. Now, because we haven't tuned this yet, the EGO correction is set to a pretty wide range of adjustments. So plus or minus 20%, it can add or subtract against whatever it thinks is the estimated airflow from the table here, and then turns that into injector pulse width. It'll go in and be able to increase or decrease the injector pulse width to hit the target air fuel. So it has some range of adjustment. We're actually going to use that to our advantage in the calibration process here for tuning this table, as I'm going to be demonstrating in the video here. We're able to watch what's going on with our EGO correction right here, and then we can use it. If it's showing it's 110, it means it's adding 10%. If it's at 90, it's taking away 10%. That's going to tell us exactly what we need to do in the table within the range we're driving it in to get it calibrated, so that this is going to be accurately representing the air mass that's entering the motor. Now, as long as we've filled in the engine displacement properly, the injector size, and the injector dead time offset or latency, we're calling it the injector cal here, as long as we have these values represented right, so displacement, the flow rate of the injector, and the latency, then the values in the table here will be valid, and we don't have to worry about any of those being off. It'll skew up what we're trying to represent, the estimated airflow or air mass into the engine. Now, we talked about this. At idle, we should be roughly 45%, 40 to 50% VE. When we're driving part throttle, we'll be anywhere between 40 to 65
VE within the table. That's appropriate.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.